Hello, welcome to the latest dose of science news from New Scientist. I'm Rowan Hooper and joined finally again by Penny Sarchet.
Hey.
Back after many months. Penny,
yeah.
Welcome back.
Thank you.
Good to have
great
you back.
To be back.
Yeah.
This week, I'm really excited that we're going to be discussing all about the microbiome. We've had some really cool stories the last few weeks on everything that's going on in our gut, how the bugs down there are interacting, how we can look after them better. So we're going to be doing a bit of a deep dive into those.
Yeah, so we've got a bit of a microbiome special coming up. But to start, there's so much going on at the moment that's within our remit in the world to discuss. There's the COP16 Biodiversity Summit in Colombia. Coming up soon, we've got COP29 climate meeting in Azerbaijan. As we know, they're both absolutely critical for fixing our planet.
Absolutely.
And then looming over all of that is the US election.
Indeed. So in a minute, we're going to hear from some world-leading climate scientists on just what's at stake in the election. But first, let's check in with what's happening at the COP16 Biodiversity Summit that's taking place in Colombia at the moment. So James Deneen, you've been covering this for us. What's the vibe like out there?
The vibe is quite something. Check out this clip from the opening ceremony.
Like a monkey rave?
So that was a performer making animal noises on stage in front of world leaders and delegates from most of the world's countries. She also did a whale as well as the monkey. I think the idea was to really give voice to the planet's many forms of life at the meeting before everyone dove into these really complex negotiations on how to stem the rapid pace of biodiversity loss, which is what the meeting's all about. I think it was pretty effective, actually.
Right. So beyond the performing arts, what about progress?
So as we're recording this, the negotiations are ongoing, final decision late Friday, but there are a few different big strands expected to come out of the summit. One is just checking in on what countries are doing to achieve a set of landmark biodiversity targets that were agreed at the previous summit in Montreal 2 years ago, including things like securing hundreds of billions of dollars in financing for nature, managing invasive species. There are lots of others. Just checking in, though, has been tough because most countries missed a deadline to report their plans. However, the information we do have suggests countries are lagging behind. For instance, one of the headline targets is to protect 30% of the planet's land and oceans by 2030. But the area protected has grown only 0.5% since 2020, which is not nearly fast enough to reach that goal. Just to describe how large that is, an area the combined size of Brazil and Australia still needs protection on land to reach that target. The protection gap at sea is the size of the Indian Ocean.
This all feels very familiar that, even when we do set goals, we're not even very good at measuring that we're doing them. We don't know how much we're doing, but what we do know still looks really bad.
Yeah, right. It's worth saying that the targets set by this particular UN treaty have never been met.
But they're not legally binding, are they? That's the other thing. Are they, James? They're just pledges, right? So that's why they've all been missed.
Yeah, that's right. I mean, they're sort of meant to spur governments to take particular action, but signing up to them doesn't commit governments to necessarily carry them out.
So can we hope for anything positive to still come out of this summit?
Well, one big outcome that's pretty interesting and new would be an agreement on using revenue from products that rely on the planet's genetic data to protect the biodiversity that really is the source of that data. This is products like pharmaceuticals, cosmetics, agricultural technology, which use a lot of genetic data in their research and development. And estimates suggest this could raise billions of dollars a year for conservation. Countries have already agreed to do this, but now they're haggling over the details, how much money it will raise, who is subject to this levy. There also has been some agreement on linking action on climate change and biodiversity loss, which are very interconnected issues, as well as a new plan to manage links between biodiversity and health. And that could spur action to limit the risk of new pandemic diseases from wildlife spilling over into people, for instance.
James, I applaud you for trying to find some positive news out of this, but, having those monkey noises on stage. And I saw at the summit, they've got this massive sort of Jenga pile there, and it's meant to symbolize what happens when you remove species out of an ecosystem. The whole thing collapses. And I just can't help thinking it's all well-meaning, but it's a gimmick. And, come on. We had someone a couple of weeks ago on the podcast saying the very fabric of life is imperiled. The fabric of life on Earth is imperiled. And, can't we do better than this? But let's finish with a clip from the Secretary General, Antonio Guterres, speaking at the COP16 conference.
So to survive, humanity must make peace with nature. We must transform our economic models, shifting our production and consumption to nature-positive practices. Renewable energy, sustainable supply chains, and zero-waste policies are not optional. They must become the default option for both governments and businesses.
Now, as we all know, it's the US election on November 5th, and I wanted to set out clearly what we could expect if Donald Trump wins, and that's just with respect to climate change. I've asked a couple of people about this. We're going to hear from Naomi Oreskes, but first, Leah Stokes. Leah works on climate policy at the University of California, Santa Barbara, and I asked her to summarize the climate policies of each candidate, and here she is.
When it comes to climate change, the stakes of this election really could not be higher. On the one hand, we've got a candidate, Donald Trump, who, he's a climate denier. He says that climate change is a scam. He said that right after Hurricane Helene hit North Carolina. And when he was president last time, he dismantled like 100 environmental regulations, pulled out of the Paris Climate Accord. I mean, we could go on for a long time. He appointed a climate denier to run the Department of Energy, Secretary Dan Burlett. He had a terrible record on climate change. And then you contrast that to Harris. Kamala Harris has a very long record on climate and environmental justice. When she was district attorney back in San Francisco in 2005, she set up the first environmental crimes unit. And she continued that leadership as the United States Senator from California, where she sponsored legislation, for example, on clean electric school buses, which is exactly what got through the Senate, during the Biden-Harris administration. And she was, of course, the person who cast the tie-breaking vote for the largest climate investment in American history. So there really isn't, an issue, maybe abortion, where the contrast could be sharper than climate change. And I think when we think about a future Trump presidency, it's quite scary. Project 2025, this 900-page document, lays out quite a scary future. Removing the word climate change from any federal agency, dismantling our National Weather Service. We talked a lot about what Project 2025 would mean on a recent episode of our podcast, A Matter of Degrees. And, when we talked to journalists, the things that they were telling us were scary. And it isn't just something that sits on a shelf. What we found is that 3/4 of the plans in these previous Heritage Foundation roadmaps end up being policy in a Republican government. So we should be taking the threat of Project 2025 really seriously.
And as she mentioned there, Leah also hosts the A Matter of Degrees podcast, and I heartily recommend that, especially the episode on Project 25, which we just heard about. And I'll put a link to that in the show notes. Now, another person I reached out to is Naomi Oreskes. She's Professor of Earth and Planetary Science at Harvard.
Yeah, I'm a big fan, and I saw her give a brilliant talk in Boston a long time ago.
Yeah, she's an actual legend. Author of Merchants of Doubt, and most recently of a book called The Big Myth. And I asked her to tell us what Trump will do if he's elected with respect to climate and what it will mean to normal people.
Donald Trump has made it clear that if elected, he will reverse the progress that we have made on developing renewable energy in America, and that he will be in bed with the fossil fuel industry to continue business as usual. What I think the American people need to understand is how much this is going to cost us in dollars and cents term. We're not just talking about saving polar bears. If you look at the events of the past few weeks, just the insured losses from Hurricane Helene and Hurricane Milton have been estimated at $80 billion. And that doesn't include all of the uninsured losses, as well as the emotional and psychic trauma of these events to these communities. The reality is that uncontrolled climate change is going to make all of us much poorer as we spend trillions of dollars, literally trillions of dollars, cleaning up the damage. And this is money that could have been spent on all the things we care about, whether it's roads and bridges, schools and hospitals, social security, national defense. All this money that we could have put into productive uses is now going to go into cleaning up the mess.
Naomi also said to me that the WHO estimates that we spent $4 trillion in losses on extreme weather events and $3 trillion in the US alone so far. And that's obviously just going to go up. And if, we've probably all been seeing the pictures in Spain over the last few days of the horrendous flooding there. You can just imagine how much that's going to cost.
Yeah, and it's really sort of surprising to hear those figures coming from the World Health Organization, isn't it? That's not a campaigning environmental organization.
Right. Yeah, it makes it more powerful. Let's just hope the message gets through. Okay, so as Penny said at the top of the show, we've got quite a lot of microbiome stuff going on this week, and we thought we'd take a deeper look at it, what we know about the microbiome. We're talking about the gut microbes that we all have within us, and maybe we'll bust some myths on the way.
Yeah, I mean, in the last, I'd say, 10 to 15 years, there's just been this explosion in science and understanding about those bugs in our guts, implicated in so many aspects of our lives now. And one thing that I've always wondered as we've been learning this is, say I get tonsillitis and I need antibiotics. What does that do to my gut microbiome? How does that affect my health and for how long? And so now there's a really interesting study out that starts to answer this question, and Carissa Wong is here to tell us all about it.
Yeah, the story I've reported this week shows that taking a single course of antibiotics for less than 2 weeks can reduce the diversity of your gut microbiome for years. This is important because when the balance of microorganisms in the gut is disrupted, certain bacteria can grow excessively, and that can lead to things like diarrhea. Researchers already knew that antibiotics can reduce the diversity of bacterial species in the gut for up to 2 years, but the longer-term consequences were less clear. They'd like to figure this out because beyond diarrheal disease, a reduced diversity of bacteria in the gut has been linked to other conditions like inflammatory bowel disease and type 2 diabetes.
This is something that I always sort of assumed that, okay, maybe if you have to take a course of antibiotics, you kind of nuke the ecosystem in your gut for a while, but over time you kind of hope that it builds back. How bad is this decline in diversity that we're seeing now over longer term?
The researchers found that the participants who had taken antibiotics called macrolides, which are commonly used to treat skin and lung infections, had 56 fewer species in their gut on average 4 to 8 years later, compared with those who took no antibiotics. And those who took antibiotics called cephalosporins, which are used to tackle urinary tract infections, pneumonia and meningitis, had 43 fewer bacterial species in their guts on average, up to 8 years later. The same was true for those who took a course of the antibiotic clindamycin, which treats certain bone, joint and skin infections.
Carissa, are they quite strong doses and quite an intense nuking of the microbiome there? Because, I know people who seem to be on antibiotics a lot, and you imagine it really make quite a difference to their microbiome then.
Well, the doses of antibiotics that these participants took were just standard prescriptions you'll get for those types of infections. So, yes, it does seem to make quite a difference to people's microbiome. Most people have at least several hundred bacterial species in their gut, so a decrease of about 40 or 50 species after just one course is substantial.
Yeah, well, it kind of surprises me there's only a few hundred species in the gut, though. I thought there might be more species than that, because there's billions of individuals in there, aren't there?
Yes, so there are much more bacteria in the gut, but the number of species is less than that. So people have estimated that there's several hundred or maybe up to over 1,000 in each person's gut. But the problem is that you can't actually identify every single bacteria in someone's gut very well.
So then if you were to lose, say, around 50 species from this mix, you mentioned that it could make you more vulnerable to things like diarrhea. How does that happen?
Yeah, so essentially if you lose bacteria due to antibiotics, that can allow some bacteria to overgrow. Like one bacteria that does this is Clostridium difficile. So after antibiotics, this can grow more than it normally would. And this disrupts the way that your gut works, and it can lead to diarrhea.
Let's bring in Michael LePage here. Michael, you've been working on a story that really gets into this sort of dynamics of bacterial activity in the gut.
Yes, so of course the guts of animals like us are one of the densest microbial ecosystems on Earth, and that basically means there's a lot of competition. It's a battleground where these rival tribes of bacteria armed with all kinds of weapons are fighting it out for resources and sometimes even territory. And what we've just learned is that these battles are sometimes won by armies of traitors that have been made to switch sides.
It's impossible not to picture actual warriors. It's like Game of Thrones in your tummy happening here with traitors and everything.
It's exactly like that.
Yeah.
Because
exactly like that.
It's just like that. Because, of course, the bacteria in our guts are competing for this limited supply of food. So for them, it's life or death. And that means these fights can get really vicious. So lots of bacteria are trying to kill off their rivals. Some of them do it by releasing toxins. Others have these really extraordinary weapons. They're sort of like dart guns that fire these high-speed syringes. And then those syringes inject poisons directly into any nearby bacteria that they penetrate. And it's just astonishing. And of course, there's a wide range of species that possess these guns, and there's also a lot of variation in the guns themselves. So the poison darts can contain lots of different types of toxins, for instance.
I want to ask more about that, but I'll just say, Michael, in your story on this, I found it really funny that, they've got these really sharp, clever weapons, and then they've got a really boring name. What was it?
They called sort of T6SS. It's type 6 secretory system. So secretory sounds like, something oozing out slowly. But no, it's an actual gun that fires at high speed.
And so one thing I wanted to ask you about is, bacteria, they can sense their environment, but it's not like they have eyes. When they're firing off these sophisticated weapons, how do they know that they're hitting the right cells and not their kin?
Yeah, so this is one of the really surprising things, is which they don't in most cases. So as far as we can tell, a lot of the time they're not actually targeting specific bacteria. They're just going around with guns blazing, shooting at anything that's close to them, and that of course includes friends as well as foe. But the key thing here is that there's an antidote to the poison in the guns, and so the genetic instructions for making a specific kind of gun comes with the instructions for making an antidote as well. So if you've firing a specific kind of gun, you've got the antidote to it, and you don't get harmed if you're hit by the same gun. To put it another way, which side you're on in these battles is determined by which gun and antidote you're using.
I mean, I do think about my microbiome a lot, in terms of what I eat. But this has made me think about it in a completely different way, these battles going on. You might just think of it as this bag of stuff buzzing around. And now it really does feel like a war zone there.
So they're fighting over food. Is it also kind of territory, space?
We think it might be. So one of the most vicious of the bacteria is a species called Bacteroides fragilis, which spews out this cloud of toxins as well as firing these darts as fast as it can make them. Now the thing is, B. fragilis feeds on these complex sugars that are found in the mucus lining of the gut. So the researcher studying them told me that she thinks the reason it's so aggressive is that it's trying to take over the lining of the gut and defend it against other related species, so it gets these sugars and they don't. But of course, the other bacteria don't just take this line down, so they've got this really fiendish trick to fight back. They've basically got these pieces of DNA that can transfer themselves from one bacteria to another. These are almost like independent entities, like viruses, these bits of DNA. And what we've just discovered is that one of these pieces of DNA that can transfer itself between bacteria, it actually carries the genes for making a specific type of dart gun and also the antidote to that dart gun. And if this gets into B. fragilis, it actually turns off production of the normal gun and the normal antidote, and then it starts making them producing its gun. And so these bacteria now start firing off guns that kill the other B. fragilis bacteria. In other words, it's turned them traitor. And then the treacherous bacteria start multiplying and sort of form these armies that basically kill off all these the normal B. fragilis around them. And that creates a space for other species to take over the mucus lining.
It's absolutely Shakespearean stuff of going on here. And I hate to ask, does it have any practical application? But does it have any practical application?
Well, yes, I think it does. So we just heard from Carissa about what sort of blunt instruments antibiotics are and how, if we kill off species, just willy-nilly. It has lots of these long-lasting effects. So if we can understand these battles going on between different bacterial species, we might be able to intervene in much more subtle ways to try and change the tides of these battles.
Give peace a chance.
Well, not necessarily peace a chance, but we want the ones to win, the ones that are good for us. We can sort of help them win, and we can help the ones that are bad for us to lose, rather than just killing everything in sight.
There's obviously a problem with antibiotics. We've got resistance is still growing. You're such an expert on gene editing. Can you foresee us kind of engineering our own little bacteria that we put in there and they targeting them towards killing the ones we want and the ones we leaving alone?
Absolutely. There are lots of people working on that already, and there are all sorts of different approaches, and these T6SS secretory systems that we're talking about today. That's one approach that's been explored. So some researchers are envisioning just releasing these. You can just sort of release these guns by themselves into the guts, and they'll go off and kill things by themselves. So that's one approach that's been explored.
But we do also know that there are a number of existing, far easier ways to positively influence the microbiome. And we're going to talk about that next. Alison George is here with us. Ali, you've written about the best way to care for your microbiome to keep it healthy as you age. And I wondered, what's the sort of biggest thing you learned in your reporting on this?
Well, the biggest thing, I think, is an understanding of just how important the microbes in our gut are for our overall physical health and our mental health as well. They supply the body with nutrients, helping tune the immune system. And also, what I find particularly staggering is how vital this is for healthy ageing too.
I think that's surprising, isn't it? It's not something you'd necessarily assume they were implicated in. How can our gut bacteria influence the way we age?
Well, as we get older, the balance of microbes in our gut just naturally changes. And sadly, there are declines in beneficial types and an increase in species that cause inflammation, which is implicated in multiple sort of age-related health conditions such as heart disease, cancer, and cognitive decline. Researchers studying older people in many different places around the world, say rural India or urban Italy, have found really striking similarities in their sort of microbiome signatures in old age. And one key finding is that people who are in really good health in old age have an abundance of distinct helpful microbes, but these are lost when there's a shift to ill health.
So that's quite exciting then, because does it raise the prospect that, by transplanting microbes or doing something else to sort of shift the ecosystem, could we sort of turn back the clock or make us age more healthily?
Well, that would be wonderful, wouldn't it? But there's a big problem here, because establishing cause and effect with our microbiome is really tough. So it's not clear whether the microbiomes of healthy older people are driving their vitality or the microbes are there as a result of it. For example, healthy older people might be doing lots of exercise, eating a certain kind of diet. However, there's some really astonishing work taking place in the University College Cork by a researcher called John Cryan, and he and his colleagues have transplanted the gut microbes of young rodents into elderly ones, and they found they reversed age-associated impairments in brain function. So maybe we could transplant the microbes of young people into older people to be healthy older people. That's the hope.
That lab that you mentioned has done some really extraordinary stuff. And another one that I remember is because it influenced behaviour. And I think that was the first time that had been shown. So it wasn't so much cognitive function, but it was actually a behavioural thing. And that was transplanting microbes from people with untreatable depression, so long-lasting depression, transplanting those microbes to normal mice. And those poor mice then showed symptoms of mouse depression.
Yeah, it's incredible.
I think all of those kinds of experiments, they're just adding to this message that looking after our gut microbiome is super important.
Yeah.
We've got to keep it in good shape. Ali, what's the best way that we can go about doing that?
Well, that's another really tricky question. This is such a complex ecosystem, and it's really actually very, very difficult to sort of say what a healthy microbiome looks like. For example, Michael was talking there about the warfare going on, but all those studies were done in the lab, and finding out what really works in people, in the wild, as it were, is really, really complicated. Carissa was also talking about the importance of diversity of microbes. And in general, greater diversity of microbes in your gut is associated with better health. But that isn't even foolproof, because you could have a diversity of bad microbes, for example. And also, some people, like vegans, tend to eat a diet that's very healthy, rich in plants, and they have lots of good bacteria, but they don't have a high microbial diversity. So it's very, very complicated.
I'm quite upset about that, actually. I try to eat a really diverse selection of foods, and, like this thing of 30 different vegetables a week. It's quite nice to actually gamify that and do it. And the idea there, Ali, isn't it, that each different thing you eat provides a different niche for a different species of bacteria, and that's why you can get a more diverse population there. But what about the science for that idea?
Well, this was it comes from science. Researchers found, I think it was a citizen science project, where it found that people who were eating around 30 different plants a week had much more diverse microbiomes than people who were eating, say, 4. But we've still much more work to do on that. There's also evidence that eating the rainbow, consuming a mix of colourful plants that are high in these substances called polyphenols, is associated with a greater microbial diversity. And there's some evidence, possibly not as much as we might like, that fermented foods such as yogurt and kombucha and kimchi increase the diversity of bacteria in the guts and also dampen inflammation. So you could, if you enjoy those, you could add them to your diet too, Rowan.
Well, they're already pretty much all of my diet, but maybe too much. I love kimchi, and I must recommend our colleague Sam Wong. He had a great recipe for kimchi, which we published a couple of years ago, I think, and I made that, and it was really great, very smelly in the fridge, but really good.
It is delicious. I wondered also, though, about fibre. This week we've got a special issue all about nutrition that Ali had a really large hand in, and I thought the piece on fibre was just really eye-opening in the role that it can play here.
Yeah, it blew my mind. So fibre is broken down by lots of microbes in the gut and provides lots of key molecules, but we just don't get enough of it. Most of us don't eat nearly enough, and it is a wonder nutrient, really.
And so I wanted to ask what we should be avoiding. Is it the kind of everybody's favourite enemy at the moment, ultra-processed foods?
Well, yes. I mean, they generally lack fibre, so that's the starting point, I suppose. And also some of the things in them, like artificial sweeteners, also affect the balance of microbes in the gut as well and their activity.
And I accept that there's probably not direct evidence of this yet, but are these the kinds of things that we could maybe do to try to counteract taking a course of antibiotics? Like, I've always wondered if yogurt plays a role, and there was a lot of praise for yogurt in our nutrition special. Is there a reason to think that they might help prevent us have, 8 years, Carissa, of reduced biodiversity?
Well, I think the science here really is at an early stage, sadly. And actually the evidence, say, of fermented foods hasn't really been built up yet. I mean, there is the strongest evidence is for yogurt, really, and that's effect on the gut. But yeah, we've still got a long way to go before we can tease all this stuff apart.
So until we know, do you have any other tips?
Well, one, if it's possible to get a handle on your stress levels, that's helpful for your gut, because stress impacts the composition of your gut microbiome and also can cause a leaky gut where your gut lining is a bit more permeable and bacteria can enter the bloodstream and cause inflammation. But yeah, don't get stressed about this, obviously, but if you can, do anything to control your stress. Also, don't get stressed about this either, but poor sleep can also take a toll on the gut. Your gut microbiome has a natural rhythm, and disrupted sleep kind of impacts that rhythm, and that's not exactly helpful. And it's possible that having a pet is good. There was a study a few years ago of dog owners, and it was found that owning a dog boosted the composition of your microbiome in positive ways.
In ways best not to think about, probably.
Yes, I was thinking that.
Well, it might be because you go out in the open and you meet other people. It might be nothing to do with ingesting dog microbes. It might be that. Or just having some exercise, maybe.
So essentially where we are with it at the moment is we don't have brilliant evidence yet on how exactly to manipulate our microbiome, but it's clear that the microbiome has loads of effects on our health, and there potentially are ways that we can really shape it.
Yeah, I think there's huge potential here. And some researchers are saying that looking after our gut microbiome should be sort of a key priority for public health. But until that message comes out, if you can, eat lots of plants.
As always, we should say here that you should speak to your doctor before seeking any new treatments for medical conditions.
And as Penny's been saying, we've got loads of microbiome stuff on our website, newscientist.com. Go and look at it and subscribe if you want more.
That's all for this week. Thanks so much to our guests, and thank you to you for listening. Do tell your friends about us and give us a 5-star rating and review on Spotify and Apple Podcasts.
We'll be back next week. Bye for now.
Goodbye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.